Dr. A. Gnanabaskaran, Professor, Department of CSE, KSR College of Technology. So today we shall see the interaction diagram. Okay, it belongs to software design with UML. The subject code is 15CB403. Okay, what is the use of sequence diagram? Sequence diagram is also called as an interaction diagram that models a sync scenario executed in the system. So you can draw a sequence diagram for any type of scenarios. So key parts of the sequence diagram. Participants. So these participants an object or entity that acts in the sequence diagram. Sequence diagram starts with an unattached found message arrow. So next component is message. It establishes the communication between the participant objects. So it has two types of line, horizontal and vertical line. Horizontal which the object pass the messages to another objects, that is the participants. And vertical line defines the timeline. So each objects, so the top row will contain the objects. It is connected by the vertical line. You can see in this example it is clearly stated. The top row or the objects which is connected by vertical lines. The vertical line represents the lifeline. The dotted vertical line represents the lifeline. And in this diagram you can see how clearly the message is exchanged between the objects. So this is an example for how to search the books in the library by author name. Okay, I think that there is a search page. Customer in the search page, he will be entering the searching criteria, that is the by author. He will be searching the criteria by author name. So he will be entering the author name, and automatically the search results will be displayed in the search result page. It's another web page. And finally, if the user entered author is wrong one, it will display the error message. So this is a scenario which represent in the use case, represent in the sequence diagram. So same thing you can code by Java program or C++ program like that. So before coding, if you draw the sequence diagram, so you can understand the operations easily. And after that, when you convert the sequence diagram to the program, then it will be easy for you. And you can see representing the objects. Already I told you that the top row represent the objects. So in the example you can see here, Smith, patient, these are the objects. And each object is connected by the vertical line. The vertical line tells about the lifetime of the objects. The vertical line tells about the lifetime of the objects. If you want, you can add the class name also with the help of the colon. So object name, colon, class name. So object name is Smith, colon, the class name is patient. Okay, if you are not having any, if that is anonymous objects will not have any name. It have only class name. And you can also include the unknown objects. If you want, you can include it. So these are the types of objects, and each object is connected by the vertical line which represent the lifetime of the objects. And you can see how message is exchanged between the objects. Already you have seen in the PPT, you can see here in this PPT the message are exchanged between the objects with the help of a line with arrow. So you can see what is a message. Here in this example, admit is the message name, and it can have optionally arguments like patient ID, room type. Can have optionally patient ID and room type. And the message again it is continued here. So you can see that the message you will be having two types. One is that you are calling, you are passing a message to an object, and similarly you will getting a return back. The return back should be done in the dotted line with arrow. Line with arrow means you are passing the message from one object to another object. That object will reply to this object with the help of dotted line with arrow. That we can see in the example, so that it will be easy for you. And you can see the creation and deletion of the objects with the help of diagram. You can easily understand. So in this diagram you can see the first object is handler, second object query command, database statement is third one. So each object is created with the help of the message, new message, and so each you can see that handler is the first object, and inside that object you will be having the query command object followed by database statement objects, and finally you will be returning. And here you can see that cross symbol is there. So you can see that as cross symbol will be there, which represents in the Java, there is no need to explicitly delete the objects, which will be going to the garbage collections. Automatically it will be going to the garbage collections. And the method calls. So you can see there is a thick box over the lifeline. Vertical line, the objects are connected by vertical line. The thick box over the lifeline is called as an activation. From that activation only you are sending the message from one object to another object, you will be getting the reply. And you can have the nesting of the objects, where in this the next diagram you can see that side, you can have the nesting also. So nesting of activation. So the activation means how long the object will be remain active. So that box represents the lifespan of the object, lifeline or lifespan. That is the time of the object, creation and deletions. So you can say that box is the lifetime of the objects. And next here you can see selection and looping. So there is some high-end UML design where you can see the order processing. You are processing order. You are sending the order, dispatching the order to careful distributor or regular distributor based on some conditions. So the set of statements inside the loop. What is loop? First one is loop. So the loop contains the complete starting flow and ending flow of one event or one process. This is called a loop. So it starts, it passes the message to different objects, finally it will get the response. This is called as a loop. So the loop contains some operations, complete operations. So and then next, that loop is denoted in UML as loop. You can see the top, there is a name called loop. And the next, inside the loop you can see alt. So where you can use the if condition. So alt means you can use the if condition. So this is nothing, it's a representation. So the value is greater than $10,000, then you are dispatching to careful distributor. Otherwise, in the else part, see the if part is above. So alt means if else. So if it is greater than 10,000, you are dispatching to careful distributor. Otherwise, else part you are dispatching to regular distributor. And there is a thing called as OPT. It's a normal if statement without else condition. So in the below diagram that is not visible, but anyway it is on one way. That is it won't have any else part, where it is without else if, that is called as an OPT. So they have used the terminology loop means complete flow, starting and you are getting the confirmation. That is for one operation. For any operation, it starts the message, sending from one message to one object to another object, and it may pass to different object. Finally, you will getting the response. This is the entire opening and closing is called as a loop. Inside the loop, if you are using alt, then it represents the if statement. If statement represents the if statement. It represents the if statement. It represents the if statement. So if you can see here in this statement, you are using opt conditions. Opt means you can use only if statement. Alt means you can use if else. Loop statement, it is tells about opening and closing of the event, which includes the data flow. And here you can see another example for loop. In this example, so where you are having storefront, chart and inventory, where you are adding, see here clearly the loop is mentioned. So you are adding an item, you are reserving the item, finally you are getting the confirmation back. So then the loop closes. Loop opens, loop closes. This is called as a loop. So an example which tells about the loop for reserving the chart items. And you can see the system forms of system control in the sequence diagram. Centralized and distributed. Centralized means you can see from the first object it is going to all objects. So the control will be passing each and every time, it will be passing from the first objects to all other objects, just like a centralized. So it is called as the first diagram, the left hand side is called as centralized, and the next each object can send its own information or message from to other objects. This is the decentralization. The second type of sequence diagram is decentralization. First type is the centralized. And this is the last part of the sequence diagram. The why we need the sequence diagram. A good sequence diagram is still a bit above the level of the real code, so you can easily understand the sequence diagram. So for understanding code, it may be difficult for you to learn more things, but non-coders can easily understand the sequence diagram. Sequence diagrams are language agnostic, so can be implemented in many different languages. So if you draw the sequence diagram, it can be implemented in Java, Python, like that. You can implement. A non-coders can do sequence diagram easily. Easier to do sequence diagram as a team. Okay, you can see many objects class at a time on the same page. You can see different objects or classes, different objects with classes or without classes. You can see how the message is exchanged between the objects. So, and you can see the loop, you can see the if part, you can see if else part. All those things are inside the sequence diagram, which represents for any scenario, for any equations. Thanks for your time listening.